Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good day. So, on this chapter, we are going to proceed with the new title, with new topics. It's related to time zero, but I have to tell everybody that in these slides, I'm not going to touch most of it. I'm going to touch the important parts of the timer zero, which is related to the interrupt that we had skipped in the first few lectures last time, because I want to make it related with these particular topics. So we are going to touch a few things only, but it's going to be quite complicated because this is not the easiest topics that so far, because I know that this is going to be very, very confusing. But anyhow, I hope that you guys can take some informations from this and try yourself by using the Proteus to look at the results. Okay, so the timer modules, which is timer zero, I'm going to touch on timer zero. 1 and 2 I'm going to touch because this is going to be touched later by Dr. Zaki. So what is this? The timer zero. So the timer zero, which is a register name, if you go back to your RAM, you can see that there's a one register named TMR0, which is timer zero, has a wide range of applications. It's normally used for writing subroutines or programs or generating pulses of arbitrary durations, pulses like the PWM, for example, that we can create a pulse which is quite uniform. Later we can try it on our Proteus, and also this can be used for time measurement or counting external pulses. For example, that if we have your clock, right? Clock here, your clock here giving the signals to your PIC. You can count the clock every time it goes down or every time it goes up. But normally we can select this one. But they call it counter. But the one that we are going to learn is about the not the counter, because the counter is the external related clock. But we are going to learn about the internal clock related to timer zero. Alright, so it's internal. Okay, let's move on. So what is the timer zero features? Okay, so what is timer zero? So there are two registers which is related to the timer zero features. Okay, so for the first timer zero, this is the one. The timer zero module timer counter has the following features, which is the 8-bit timer counter. So timer zero is an 8-bit size counter, which is your RAM 1, 2, 3, 4, 5, 6, 7, 8. So it can start from 0, 0, 0, 0. And it can start to count maybe here 1, 0, 0, 0. This is binary numbers. And later the final number will be the final number must be 1, 1, 1, 1, 1, 1, 1, 1. That is the final number. So it can count from 0 to 255. It can count. This is timer zero. The counting is uniform by having its frequency of the clock, the what you call that, the cycles, the instruction cycles, all the stuff, the instruction cycle. So this is related to this one. Okay, so this is an 8-bit timer counter, which is this one. It must count from 0 and going above. It cannot count backward. Okay, it must start from a lower number, then it can count to up to a higher number. Okay, so it's a readable and writable, means that this register, you can write any numbers that you want. For example, that if you want to start a number from the register, maybe you want to start from this one, for example. Okay, then it can start to count here like this one, 1, 0, 0, 0, 1. Next one is 1, 0, 0, 0 up to 255, right? So this is the readable and writable. So you can read this timer zero registers, and also you can write it. This is the 8-bit software programmer Prescaler. So what is Prescaler? This is a new thing for you. Prescaler is the one that can divide the frequency that we have. Divide. For example, that if you have the frequency is up to 20 megahertz, right? Means you have the prescaler, means that prescaler, the value prescaler is going to be possibly maybe 2, means that you're going to divide the clock to 2. That's why they call it prescaler. It's just a division of the clock. Okay, so internal or external clock select, this is the one that I talked just now. For the external, we are going to talk about the clock outside just now, the clock, but internal is the one that we are going to use timer 0, internal clock, so we can use it for the interrupt. Okay, so the interrupt happens, okay, this is the definitions. So the interrupt happens when overflow from FFH, which is the hex number, to 00H, which means that you have to convert this one to binary. This is going to be 1111 1111. So this is the maximum number it counts. So after this number, it will go back to 0, back to reset. Means that after this number finish, it must reset, go back to 0. So when this condition happen, they call it overflow. When this condition happen, the interrupt happen. So that is the big thing. It counts, the timer 0 start to count every time the clock is there, the instruction is there, it will count up to the highest value, which is 255, which is all 111111. And after that number, it will go back to 0. And this process, they call it overflow. Okay, 255 back to 0. And then this is the overflow process, which means that the interrupt had happened. Okay, so that's why we are going back to the interrupt slides later. So anyway, we just proceed. So this is the H select for external clock. This is, we are going to talk about the counter. I'm not going to touch about this one. So the registers associated with timer 0. So there are two registers related to the timer 0. Last time we learned about the incon, which is the interrupt control register. If you can remember this is the register that where you need to set if you want to use any of the interrupt. So we have 3 interrupts last time. So we have the RB0 external, which is this one, and the flag is related to this one, which is, this is the flag. Okay, and you have sorry, this is RB, this is sorry, this is should be RBI. This is changes on RB4 to RB7 if I'm not mistaken. So this is RB0 external interrupt. So this is its flag. And you have this one, the timer 0 interrupt enable pin, which is bit, this one, and this is its flag. So the flag is the thing that telling the system the interrupt had happened. So you know that if this one is 1, means that there's a flag saying that the interrupt had happened. So you have to go for the interrupt functions to complete, and then you have to clear back the interrupt here back to 0, and then you can go back to your main program. Okay, this is the last time on the option rack. Now the new one. The new one is related to option register. Okay, this is the option register, another register that you need to set if you are using timer 0, because this is the numbers that giving you the prescaler value. Okay, so the one that you are going to change, and in fact the prescaler is these 3 bits. Okay, the rest you just need to change this one to enable this one. The rest is all 0, and you need to change accordingly to what value that you want for the prescaler is at these 3 sections. So what is the value for this one? Of course, this is can be only 1010, right? So we are going to look at the option rack register. So what is option right? So we are going to look at the option right. Going to open up this one first. So option right. Option register is containing various control of bit to configure the timer 0. Okay, prescaler. This one I don't want to touch the watch.timer prescaler. I don't want to watch. I don't want to touch this one. And then this is the rest is the external interrupt and timer 0. This is all I don't really want to touch. But we're going to touch about the last 3 bit over here. Okay, this bit you need to set, or when it's set, then you should know that what is the prescaler is being used. For example, if you are having this value as 1, 1, 1, so you have to look at the definitions of the bit 2 to 0, the prescaler rate select bits. So 111 means you are selecting this value, and the prescaler you are using is 256, which means that your frequency will be divided to 256, your frequency. Then another example, if I want to change this one to 010, so you have to look back at this table again. You have to select which one is 010. 010 is this one. So the prescaler that you are using is 8. You are dividing it into 8. 1 over 8. This is the ratio timer 0 rate. You are going to divide the frequency to 8. So this is the prescaler. Without this means that you can have your own frequency back to normal 20 megahertz. That's all. Means that if you are using the timer 0, you must set this one. Okay, the lowest one will be 000, is you need to divide by 2. So that is for the option right. Okay, they will call it option register. So go back to this one, timer 0 feature just now. This is the one that I had discussed just now. So what is the 8-bit timer counter, which is timer 0 has a register called timer 0 counter, which is a 8-bit size, which is this one. So we can write the desired value into register, which will be increment as the program progress. So it means that when the program is progressing, your timer is going to be counted every time. It will not stop. So the frequency varies depending on the prescaler. Just now, when we look at the option right register just now, then you set the last 3 bits, you can see that which one that you need to divide on the frequency. So based on the 8-bit over here, the maximum value that can be assigned to the register is 255, which is another value which in binary is this one. So 8 bits timer 0 is 2 to the power 8 is equivalent to 256. It's around 255, right? So from 0 to 255. Right, this is the one. So this is the meaning of prescaler. A prescaler is an electronic counting circuit used to reduce high frequency. That's why they divide it to low frequency by integer division. That's why they call it prescaler. Prescaler is a new term, but the function is very simple, is to divide the high frequency to lower frequency by a division numbers. So that is the theory on the timer 0 features. Okay. So this is a prescaler just now that we look about the 3 bits just now, the S0 to S2, the 3 bits. So this is the one that just now you select this one, 000. Then you can go back to this one. You look at the data sheet. You must look at the data sheet and which one that you want to select. Okay. So next one is back to the incon register. This is just a recap. This is where the register that you need to set to control your interrupt. So in this case, we are going to use timer 0 interrupt enable, and we also need to look at the timer 0 interrupt flag. This is going to say that if you are flagging this one as 1, then the interrupt had happened, then you have to reset it back to 0, which is cleared by software. If I'm mistaken, you see this one? Timer 0 interrupt flag this is a timer 0 overflow interrupt flag. This is overflow. Remember that when the counting finish from 255 back to 0, this is the condition of overflow. So this happened, the flag will be set to 1, and then after that, timer 0 register has overflowed, must be cleared in software. If you have this one already means that interrupt had happened. So after you finish your interrupt, you must clear it back to 0. That's why they call it must be cleared in software. Okay, so this is the interrupt control register, and this is the one that we learned about the flag just now. I think that you should understand before this on the last one, the RB0 external interrupt. And this is the option register, and this is all about the circuitry and the function now. So I'm not going to touch this one as a timer mode. No need. This one 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 no need. This is the one that we are going to learn. Okay, because this is related to the interrupt, so I'm going to touch this one. By right, Dr. Zaki will take over again in timer 0 and timer 1 and timer 2. But I have to touch first because it's related to the interrupt. Okay, so how to use this one in interrupt? Okay, so interrupt occurs when value of timer 0 overflows from FF. This is FF, which is 1, 1, 1, 1, 1, 1, 1, 1, back to 0. By default, when you start a program without doing anything, your timer 0 is equivalent to 0. So as the time goes by, this timer 0 will be counting accordingly, uniformly related back, uniformly, and relates to the clock, external clock that we have. So every time your program starts, as long as it's still working, your timer 0 will still be counting uniformly. 0, 1, 2, 3 in. This is in decimal. By right, it actually should be like this. 0, 0, 0, 1, 1, 0, 1, 1, something like that. So when overflow happens, the timer 0 interrupt flag bit is set, which is a TOIF just now, must be cleared in software to enable the text interrupt to happen. So if you do not clear the software, in the software, means that the bit still 1, the system always think that interrupt still happen. So it will always go to the interrupt void function, always inside there. It will not go back to your main program. Okay, so timer 0, how to enable it? You have to timer 0 interrupt is enabled through timer 0 interrupt enable in the incon register. So this is the register that we use to control, or we use to set which type of interrupt that we want to use. So this is the one in chapter 2 last time. Okay, let's move on. Okay, the example of interrupt here, the one that I'm going to touch, I'm going to write again this one, but a bit different from this example, because some of the example here you can see that it's changing the value here, 0x this in hexa. I don't want to make you guys confused at the moment, but I may use this one in your finals, maybe 0 times or whatever decimal number that I want to change, or binary numbers. So you have to consider that if I use this one, means that you have to change it to binary to look at what are the things that have been set. Okay, so let's try to write the code, main code over here, and we have the interrupt. So what happened? Okay, so I have the code over here. So again, in the beginning, it only have the void main here. Remember that when we have a new code, it will start from here, void main, and only this one, void main, bracket, and this one. So I have to start to write option rec is equivalent to 0b 1000000. So remember that this is the one that we are going to look at. 0000 means let's look at the slides again. For 000 means that I'm going to use a prescaler to 2. So the frequency will be divided to 2. Okay. So next one. After this option, right, so I'm going to enable the interrupt. You remember that the incon register must be enable the timer 0. Timer 0 is, this is enable for general. I mean the whole thing, you need to set up this one as 1. Because you remember that by looking at the incon register, okay, incon register, the first one is global interrupt enable. So you must enable all the global interrupt. Okay, 1. So this one should be 1. And this one 0, this is 1, timer 0, and the rest must be 0. Which is correct, this one. So I had set 2 registers. The first one is option right, and the second one is incon. So I'm going to use port B to have the results. Again, this is very simple for you guys. So 7 weeks already. So choice B is the one that going to set your port B as all as the output. So I'm going to use only 1 pins. Never mind, I'm going to set everything there. So the first initial value voltage from port B, I'm setting up at 0 volt. Okay, CNT means count. So this is a variable. In C++, you must declare any variables if you want to put inside your program. So for example, here, this count is a number. So I'm going to assign it, I'm going to declare it as unsigned. Unsigned, you have to go and check what is the variables related to unsigned. This is the name of the unsigned. So my count start at 0. Okay, so this one I'm going to remove first. So now this incon telling us that the timer 0 is the one that we are going to use. Okay, so this is the one that we are going to use. So I'm going to take out this one first. So this is the loop. The one that always, the loop going to be infinity, because once it's going in while 1 here, it's going to be loop all inside here. So look at the code here. The code say, the syntax say, if count is equivalent to 1, then my port B will be invert. What is the latest value will be will be inverted here, and then this command is to reset back the count. So what does that mean? So the port B right now here is all 0 volt. Okay, let's draw this one. So if you run, your program starts, right? So the voltage out from port B now is 0 volt. Okay, because it's start, right? And then your count at while 1 here is checking the count is equivalent to 1. So is it counting as 1? So your count still 0 here, right? And your timer is still counting. Your timer start already counting. Timer 0 start from 0, now counting. Go up to 255. So while going here, your count is still 0. So if count is equivalent to 1, then it will go inside here. But now your count is still 0. So what happens is, if this count is not equivalent to 1, so it's going to jump outside from this loop, from this bracket. So just jump out here and then go again check. So when is the count going to be changed to 1? So remember that your timer 0 is still counting at the background. So this counting happens at the background. Count up to 255. You have to imagine this one. And then you go back to reset to 0. This is the overflow condition. And this one setting up your timer 0 in a flag. So when this one happen, your program will go to in interrupt, right? So what happened here, it will go to interrupt up here because the overflow had happened and the TOIF is already 1. Because this condition flag this one, the interrupt happened. So right now your count is plus plus, which is your count plus plus mean is equivalent to current latest value count will be plus to 1. So the first value is 0 plus 1 and the value now is 1. So this command is incon 0 times 20. What does it mean? So incon now is equivalent to 0B00100000. Remember that the TOIF is over here if I'm not mistaken. So this command is to reset the flag back to 0. This is cleared by software. So this is to clear software. Right. So once this count 1 already, right, complete and will go out back to this one, this while loop, then it start to go check the count again. So you can see that now if count is equivalent to 1, yes, your count now is 1 already. So what happened is, if this count is already 1, you have to invert the port B here. So that's why just now your value for port B is all 0 volt, right? Based on this one just now. Price B, port B. And then suddenly after the count 1, there's going to be up here. And then your count is equivalent back change to 0. So this is resetting back your count. Means that your count now is back to 0. Okay, once this count back to 0, you remember that the timer still is working at the background. The timer is still at the background counting. Keep on counting. No matter what happened here, the background still counting. So now, it will go back to the same position again, 255 back to 0. Then the overflow happened. So this is again back to this one. Then you will do this one, C plus count plus plus, which is back to 1. And then reset back the flag and then go back to here. If count is equal to 1, which is already 1, so it will invert back the port B value of voltage. So you can see now, your value from 5 will go back to 0. And this process is keep on repeating and having this value. So how much is this one? And how much is this one? Okay, that's the importance of the option register values. Okay, the formula. Okay, the formula is like this. I'm going to just give you the formula. Okay, the formula to look at the value for the time. Okay, if you want to look at your book, you can go directly to the timer chapters, which is at 144. Okay, the formula is F out is equivalent to F clock by 4 times Prescaler times how many counts in timer 0, and this is the count C and T just now. So this is the formula. The 4 is related to, remember that, one instruction cycle, is 4 something like that. It's something about 1 instruction cycle is equivalent to 4 clock cycle. Remember that this is a instruction cycle is 4 for so this is a 4. PC is prescaler. This is the one that you select. For example, just now in the last 3 bits is 0, 0, 0. This is going to be 2. Timer 0, how many bits is counting? Once is going to be overflow. For this case just now, it's going to from 0 to 255. So the whole value will be 255. Okay, now look at the results here. So the clock that we are going to use normally is going to be 20 megahertz. Okay, so 20 megahertz divide by 4 divide by 2 divide by 255 divide by 1. So let's try to look at the calculator. Okay, 20,000 divide by 4 divide by 2 divide by 255 and divide by 1. So you can get that this is the F out frequency out, which is 980392. 980392. 9803.92. So F out for the T, so it means that this is the F frequency, right? So T is equivalent to 1 over F out. So you go back to your calculator. So 1 divide by the answer just now, you can get that this is around 1.02. 1.02 times 10 to the negative 4. So now I can say that each one count over here. Each one count because every count you will revert, right? Each one count here. The value will be 1 to the 2 times 0, negative 4. Same goes to this one, same goes to this one, same goes to this one, same goes. So let's try to look at the results. If I'm using this one, right? So let's just build this one and then run it at the Proteus. So you can set up this one, look at the result from RB4. Okay, so now run it. So you can see that this is the value of the, I'm going to change, this is the one just now. It's very uniform, you can see that. Right? So how to calculate this one? Let's try to have a look, make it bigger. So you can try to, this one just now, put a cursor here, right? So you can try here, this is from 0. And then this is around 1.2. Yeah, correct. So this is 1.02. So the difference, this one is microseconds, 102, which is the one that we calculate just now. This is 102 microseconds. This is equivalent to 102 microseconds. So let's try another one, which is maybe from your example at page 144. That one got problems on the returns on the book, so I'm going to change it, right? So the value right now is different. Okay, now look at the results here. The command here, you can see that the timer 0 is not starts at 0, so the timer 0 now starts at 96 here. And then also another one that the timer 0 is setting up at, again, is over here, which means that it is not set by default at 0, it will set at 96 start. Okay, it will start over here. So now remember that once the 255 complete, it will go back to 0. That is the case when the overflow happened, right? So now, let's try this one. Your timer 0 is not starting from 0 anymore. Okay, now your timer 0 now is starting from 96. Timer 0 now is starting from 96. So you will count up to 255. So the difference within this period is 255 minus 96 is equivalent to 159. 159, correct. So inside the book, that the module, in the formula down there, the timer 0 is wrong. The timer 0 in the book say that this is the one, 256 minus timer 0. This is at page 144. So this is wrong. It should be directly is 255 minus 96, which is not 255 minus 159. This is wrong. This is, should be 96. So you finally can get 159. So if you put all these things and you still use the same Prescaler, which is set up for option rack. Okay, option rack, maybe just now add 2 again. So we can get the results here. Going to be F out. Remember that this is F clock. Divide by 4. Divide by, this is the Prescaler. Divide by 2. Divide by the timer 0 counting, because this is the numbers, right? This is the one. 156 and times 1 CNT. So what happened here? Okay, before I proceed, let's look at the command here. Let's look at how it works. This is, you know already how it works. This is the one. Timer 0 start at 96 and count start at 0. Of course, you have to start from 0. So when you go to this loop, you will check the count whether 0 or not. If there's no 0, it will jump out from this loop going outside here, which is nothing here. Nothing to do here. So you go up again. So at the background, your timer start from 96, right? So it's counting 96 up to 255. So after 255, you want to go back to 0, reset. So the interrupt must happen. So once the interrupt happen, right? So this is the one. Interrupt happen, you will go up here. And again, the count plus plus is just now 0 plus 1. And then your timer 0 is going to be set to 96 again. This is to clear it. This is setting up your timer 0. If you do not put this one, means that your timer 0 is go back to 0, which is the same previous example that I have just now, which is totally wrong. So this is the one that we have to set back the timer 0 condition default at 96. So it will count back from 96, 97 up to 255. And then if count is already 1, it will go here and then it will invert back this one. So again, if you look at the result just now, here you have this one, F clock is equivalent to 220 megahertz. Let's try. Divide by 4, 2 times 156, 1 count. This is equivalent to what? So let's look at the 20,000. This one, 20 mega. Divide by 2. Divide by 4 just now. Divide by 156. Divide 1 count, doesn't matter. So this is the F clock, right? F out, this one. So the period will be 1 over this one. So I just want to go directly 1 divided by answer is going to be 6.24. 6.24 times 10 to the number. Let's try to look at the result. This is the T for this one. So whether it's correct or not, let's try. So project build again. Close this one. If you accidentally close this one, don't forget, you can go back to debug and then look at the digital oscilloscope. So you just need to stop at this button and then run again. So now the value is what? Let's try to have a look. This is starting from 0, and this is it the same one just now? Or maybe I'm not really using it at the moment. Let's try 96. Oh, wrong. Timer 0 here. It's not built up, right? So project build. So something wrong again here. Very simple wrong. Timer 0, register, build. Then you want to try this one. Okay, let's run it. Look at the results. Where's the debug? Which is this one, which is the oscilloscope. Now the value is a bit different. Let's try to look at the result here. This is 0. And here is around 67. Is it the same one that we get? Yeah, around 6.24. So this is of course I have an error like putting this one. So more or less it's 67 microseconds. So this is like this, the value is there. So this is correct. So the difference just now is the one that we are not changing the timer 0 value, which is the one by default is starting from 0. But now we are changing it to 96, which is the one that we don't want to start from 0, but we're going to 96. So the difference is from the value counting is starting from 96 to 255. So it's a bit different. So this is the method how you want to use interrupt in timer 0. Because interrupt in timer 0 can give you a very good uniform value of pulses, right? So for example, this one can be used also to drive your servo motor. Remember that last time I teach you guys a very simple method, just use the delay function. But by using this one, right, by using the interrupt at the servo motor, you can generate the value for controlling the servo motor, which is for example that 1 millisecond. Remember that 1.5 milliseconds and 2.0 milliseconds. You can try here. Okay, let's I just want to show you on the servo motor. This is the last one. So the rest of the example you can look at the book, right? You have to find out the values over there. So for the servo motor, you can go back to the module at page 87. So that one is quite confusing on the code because it relates to port A. So I don't want to use port A at the moment because port A is always reserved for the A2D version, A2D modules. So let's try to change it to port B. Okay, so let's try to have the code like this. So I'm going to change the code over here, right? So the incon is equivalent to this one, A0, this is 10, okay. I just want to refer trace B, this is the one. Timer 0, I'm going to use start from 0. So this is going to be removed. Also this one is going to be removed. Okay. And then while 1, okay, let's change the while 1. I want to take one by one first. I don't want to confuse you guys. If count is equivalent to 10, port B going to be 0. And the count no need over here. Set it. Please refer to page 87, right? So I'm going to change accordingly. Okay. So this is I just want to take one signals only. So the first one is a port B. I don't want to go for specific pins, doesn't matter. So count someone, if equivalent count is equivalent to 10, then your port B is going to pull down. Okay. So let's look at the interrupt. For the books, you can see that for the interrupt here, so the count plus plus, then if count is equivalent to 200. Then what happened here, this is the bracket, your count will be reset back to 0, and then your port B value of the voltage is going to be all 1. 0 times FF is equivalent to 0B, 1, 1, 1, 1, 1, 1, 1, 1. Then that's all. Alright. So, okay, so this is the one. So let's try to change it in the Proteus by using servo motor. So this one just gets servo motor here. This is going to be a long lecture, 1 hour lecture. Servo motor is a PWM. Okay, I'm going to use the pins from this one. It's the same because I'm using all the pins, the same results. Doesn't matter. So this is a power. And this is the ground. Alright. So let's run this one. Hopefully it works. It works. Hopefully it works. So the first one is 10. So build. The first count is 10. Okay, let's look at the result here. Yeah, now it's equal to this value. So what's the value here? This is around 1 millisecond. Okay, 1 milliseconds. And then 1.5 is 15. Change this one if count equivalent to 15. Let's do this one first, and then I'll tell you what happened over here. Then build this one again. And then look at the results. Nearly at 0, right? So the value here is 0 to 1.5, 1.53. Okay, that's nearly the same on the 1.5 milliseconds. Okay, next one. The last one is 18. 18 here. You can change to 18. Okay, project. Okay, run. So this is around 0, 1.75. So I don't want to make it, you just need to use 1.5, right? So I'm going to reduce the numbers, not 18. I'm going to change to maybe 15. Whether it's going to be 180 degree or not. Build. So run this one. This is 1.5. Why? It's correct at 1.5, right? So this is 1.5. It should be 2, sorry. The longest one should be 2. Sorry. 1.5. This is 1.5. 2 means you have to go up to maybe 20. Let's try. Build. Yeah, 20. So this is 0. This is 2 milliseconds. So this is related to servo motor. Okay, how it works. So look carefully. Okay, your code say what? This is the code, Don't go for the interrupt first. Go to the main over here. Okay, the option register is the one that giving you the prescaler value. So the prescaler value now is 000, which is divided by 2. Go back to your option register. You can find out this is related to divided by 2. So in count is to set up your timer 0 enable interrupt, and this is the flag still 0, means that the interrupt has not yet happened. This is to declare your port B, and your count start from 0. Okay, the count must be put as unsigned count over here. The count must be start from 0. So look at the component over here. Your port B now, so sorry, is it correct, my port B? Just want to confirm. Yeah, this is the initial value, doesn't matter. This is initial value. This is just initial value. All right. Now, what happened is, when you run your program, your timer 0 start to count from 0 to 255. Okay. Your timer 0 start to count from 0 to 255. Okay. Now, when it countings and go back to 0, this is overflow had happened, the interrupt must happen, correct? So it will go up because your count is still not yet 20, is 0 anyway, so it's going to be keep looping at this one. If count, then will go out here and do this one, nothing. Do this one, nothing, do this one, nothing, right? So now you will go to the interrupt once the counting had completed and overflow happens, it will go up. Counting plus plus means that your count now is going to be 1. So inside here, you'll check if count is equivalent to 200, this is still 1. Then you have to do this one, but nothing happened here because your count still 1. Then you will go out here and then reset back the flag for the interrupt. So you go back here again, check if count is equivalent to 20. No, it does not. Right? It does not, right? So means that your port B still at this value. Okay. Oh, sorry, I have to change this one, I think. Doesn't matter, this is one. So the first value will be all at 5 volt. Okay. So this is the default value for your 5 volt port B. So it keep on having at this state level because your count still at 1 just now, and it's going here. And then the timer 0 at the back still counting. Still counting. Do the same one again. Go up again here and then count up to 2. Count is equivalent to 2. Right? Then here check. Count to 200. No. It will go up here and then do this one. Go here. And then keep on repeating up to your count is equivalent to 20. So right now, what happened is your port B going to be changed to 0. This one going to be changed to 0. This is 0 volt. And then after this one, your counting still happen, right? So the 0 volt is still having this one. So this is around 20 count. And this is the one still having this one because your count still happens counting. Because here, the reset will be back to 0 if your count reach 200. So if your count reach to 200, then what happen is, you'll go here, if count is equivalent to 200, your count is going to be set to 0 again, but your port B now is going to be set as 1. Go up back, sorry. This is go up back. So this is around 200 count. This value is going to be around 200 count. And the 20 count is around this value. Right, so you can see that one. So the process is going to be the same one all the time. So that's why you have to read this one carefully, because this one is already count back to 0. So means that the count back to 0, you will check this one. Then you can see that this is the value that will be coming out from here. So let's calculate what is the value of the time here. So go back to your formula again. F out is equivalent to F clock divided by 4, the 4 cycles, divided by, this is 0, 0, 0, is divided by 2, divided by the whole timer, 0 is 255. And how many counts? This is 20 counts. And we are going to calculate this one. Where's the calculator? All right. It's not moving. Okay. So 20 megahertz, 2, 3, 4, 5, 6, divide by 4, divide by 2, divide by 255, divide by 20. The first stop, this one, is equivalent to this one. So this is the F out, but you want to see the period is 1 over answer. This is the one, 2 milliseconds, around 2 milliseconds. So the value here is around 2 milliseconds. So I went to 200 counts. Let's look at the results here. Let's try again to calculate. All right. So 200 count. Sorry, 200 count is not this one. 200 count is starting from the beginning here. So 200 count is from here to here. All right. So 200 count. So 20 megahertz divided by 4 divided by 2 divided by 255 divided by 200 is equivalent to this one, and you got to calculate the period is 1 over this one. Then you can get the answer is around 20 milliseconds. 1, 2, 3. This is around 20 milliseconds. Remember that this is the patterns or the PWM need to generate to control a servo motor, which is this is 0 degree, this is 90 degree, this is 180 degree. So this is at 1 milliseconds, this is at 1.5 milliseconds, and this is at 2.0 milliseconds with a period of 20 milliseconds. So you can see that this is how, by using the interrupt, you can control the position of the servo motor. Okay, so that's why you can try yourself by looking at the books on the servo motor. There's a value here, maybe not 20 anymore. This is going to be 15. You can calculate this one. So the book is wrong, not 18, it should be 20. 15, you can create this one maybe at 10. Then you can calculate. Means that by using this one, you can calculate the value here. This is going to be 10 counts now. And this is still 200 count because of the counts here is still have this count. So this is the value. Then you can calculate when 10 is must be around 1 milliseconds only. So it depends on the prescaler here because the prescaler can be changed, okay? So this is not the one that always, you have to look at the option register. What is the prescaler value? For this example is 2. Maybe later I can put 4, put 16 or 32 is up to me. It's the same thing. All right. So I think that's all for this lecture. It's going to be 1 hour lecture. Yes, it's very long, but I have to make it very clear with you guys how it works. So today's topic, we are learning about the timer 0 interrupt, where this interrupt is taking the knowledge, the value, the information from the timer 0 registers, and then we can apply it on getting a good signals, which is going to be like a PWM. You can control an LED or you can control a servo motor. So this is a theoretical behind on how you have to calculate the F clock, F out, and its period time. So that is the this is the last lecture for me to complete all the syllabus that we are going to cover in the finals. All right. So do not forget to complete your assessment in ULearn. I'm going to open up the Ulan longer this time. All right. So wait for my announcements, and all the best to you guys. Thank you very much.